is they are literally constant whenever you think about them. They look like gobbledygook. They look like gobbledygook when you look at them, and you like this. Look at the intermediate value theorem right here. There are a couple of things. Listen. There are some definitions, of course, that you have to commit to memory. One of those is the definition of continuity, which is why, tell me.
The limits of the right equal the limit of the left equals the function value. Look at us now.
And the definition of a limit?
The right equals the left.
I'm telling you, y'all are already in for limit. What am I trying to say? For limit concept, y'all are already on 4-5 level if you can convey that. I'm telling you.
Do we understand better than your last year's?
Yes, y'all are. That's what I'm saying. I know y'all are feeling overwhelmed about it. I'm feeling outstanding about it.
You break down yesterday.
No, I said y'all felt bad. Y'all are putting a lot of pressure on yourself about. Great. I'm worried about grades. I'm worried about grades. I'm worried about my grades. I'm worried. I can be worried about grades. Yeah, this is it. This is the end of the chapter. This is the end of the chapter.
Oh, this is it.
All right.
What is land?
I do not feel bad. We're going to come back to that right now. I don't want to throw any other freak-out concepts that I'm going to have to read right now. Because that's going to get into polynomial long division, and I just don't feel like getting bogged down in that right now. It's so little if it shows up. There's probably like 2% chance that that's going to show up, and if it doesn't, one multiple question, and it's not enough. I would rather spend some time on some other. All right. So I wanted you to feel good about that because already on like those AP classroom questions and stuff, y'all are at least able to get through and answer those. Sometimes they might be hard and you might have to struggle with them. Last year was a disaster with AP classroom questions. So I'm feeling a lot better about it, so you should feel better about your too. Y'all really are doing a good job. I know, Addie. I know you feel like you're not stressing to the max, but don't. I will tell you if I can do stress. And quit stressing about your grades. Because those are gonna. Like I wish we had Power School like before where we could not publish the like. I do though. I have to. All right, intermediate value theorem. That looks like a lot, right? F is continuous on the closed interval. Now, here's the only thing I'll tell you about theorems. They always start with an if part, and that's very important, okay? Because when they have an if part on there, and you have to use that theorem, that's what you have to show before you can use it. So you have to show the continuity, which is left-hand limit, right-hand limit, function value. Or the problem would state the function is continuous, and you would say because this is a continuous function. So you have to include that for that part of it. So, all right, so f is continuous on this closed interval AB. K is any number between f of A and f of B. There's at least one number C such that f of C equals K. That is a mouthful, right? And you're probably looking at it going, what in the heck? But it is not as bad as what it seems. All right, so let me explain it to you. I feel like that looks ugly. Huh? Wait, no, what? I know. So it looks bad. All right. I'm on this interval, right? I've got this random function. I like how Mark Corelli explains it whenever he does these kind of things. Did y'all like him, by the way? All right. So here's what this is saying, and when you see it written out, it just makes sense, and you go, well, duh. All right. I've got a continuous function that is continuous on the closed interval from A to B. Is that continuous between A and B? Yes. So it meets the background criteria, right? K is a number between f of A and f of B. Well, this is f of A, right? This is f of B. F of whatever is your y value, right? So K is somewhere in between those. And it says that somewhere in between, there's a C in here that if I plug it in, it's going to give me K. In other words, if there's a K somewhere in between here, then there has to be a number I can plug in to get K. There has to be something that falls in the middle. That makes sense, right? That's the theory. There is a ton, but all I'm worried about is, well, if I know that K falls between A and B, then I know there's a C in here that has to give me K. Because it's in between somewhere. There's no way to get in between without touching a piece of that graph. So somewhere on there, there's a graph that corresponds. That's all it says. That's all it says. It has to be what? Right. It has to be continuous. If you had a piecewise that was a jump, it wouldn't work. So, yeah, it would be, yeah, does not exist. I'm fixing to show you. I don't want to show that yet, though, because you got to know differentiable. I think other than telling you what this is, I would really rather spend some time. Let's look at example 1 on here. Let's look at example 1, and then we will practice. I would rather spend some time practicing with. Conceptually, I feel like they're the hardest. Everything else is so straightforward to me. Yeah. Revolutions? They're not bad. They're really not bad. They're really not bad. All right, let's do a couple with IVT, and then I'm going to set you loose on something else. I know. All right. Let G be a function such that G of -1 equals 0 and G of 2 equals 5. Which of the following conditions guarantees that there's an X between -1 and 2 for which G of X equals 3? So let's remember what all has to happen, right? I have to be what for this to work? Because I'm looking, this is my f of A and f of B, right? Yeah, we can draw it. But it needs to state, so it says, which of the following conditions guarantees that there's an X between -1 and 2, where it equals 3? Okay, so let's see. -1, 0. I know, it's kind of cool. 2, 5. We all in agreement? I don't know what's happening in between, but that's what I need to know. What has to happen between -1 and 2 so that G of X has to equal 3? So that's the IVT, right? That's saying that there exists, but what conditions have to be met? It's got to be continuous. And think about this. If it's continuous, that already means it's defined, right? But just because it's defined doesn't mean it's continuous. So definition does not guarantee that there's one in between. Does it matter if it's increasing? No, because I mean, I could come in here and start decreasing during some of it. It doesn't matter. So no, it doesn't have to be just increasing. And does there have to exist an x in that range between -1 and 2 that g of x equals 6?
Absolutely not.
No, that doesn't have to be there. It doesn't have to go up here above it. That's not one of the, so it just has to be continuous. So you're just testing to see if you have.
Oh my God, that's not a fun.
Well, it's not included. How about the, oh, sorry. This is literally the sheet that I had due for classwork today. That's why I said I'd rather just go over a couple of them and
Let me see it, please.
that, no, not right now. Sorry. Tell me when you're done. The table above shows selected values of a continuous function. So look, they're already telling me it's continuous. Even though this is a discrete step, y'all know the difference between discrete and continuous. Discrete is just points, it's disconnected, but continuous, I don't have to lift up my pen. All right, so the table above shows selected values of a continuous function. I'm on the interval 0 to 13. What's the fewest possible number of times that f of x equals 4?
4. 1.
Fewest possible. So it does at least this many times. At least one time,
No,
right?
2. Because look, there's 3.
This is
So it goes up. It has to go up to 4.5 and then down to 3.
okay.
So for it to go up to 4.5, it has to touch 4.
Okay, he's right. He's right with the way he's described. He's just okay. How many times does it at least the number of possible times to 4? So here it's going from 3 to 4.5. It has to touch 4 there. That's 1, right? Then we're talking about the y value. Then it goes back down, so there's another one. It's got to cross over 4 there. You see how it just makes sense? It's got to. It can't go from 3 to 4 without hitting 3.5, or it can't go. You see what I'm saying? That's IVT. It can't make it from one point to the next without crossing everything in between it at least one time. So there's 2, and then there's a third. That's IVT in a nutshell. That's easy, right? All right. For IVT, yes. You just have to be able to recognize when they're asking for it. Like if this was a multiple choice question, you'd have to understand, oh, they're asking me about IVT. Or if it was FRQ, they would have to say, but we'll practice with that. I'll give you a memorization sheet and we'll practice with it. All right.